Welcome back everyone to Learning by Teaching. Today we're in dynamics and we're going to solve this problem 16.12, okay? So it says the power of a bus engine is transmitted using the belt and pulley arrangement shown. If the engine turns pulley A at WA, angular velocity of A equals to 20t plus 40 in radians per second, where t is in seconds, determine the angular velocities of the generator pulley B and the air conditioning pulley C when t is equal to 3 seconds. All right, so we're given basically an equation to describe the velocity of this disk, and what we're asked is to find the velocity of disk B and also the velocity of this disk C. Okay, so the first thing I like to do always in all these problems, let's just write out our givens. We're given that the angular velocity of disk A is equal to 20t plus 40. And they're also giving me that the time that I'm interested in, I'm gonna call it t1, is equal to 3 seconds. Okay, so after this, basically now that I have my time and then I have the angular velocity describing the time, so I'm just gonna go and evaluate this angular velocity of A when this is equal to t1. Well, this should be equal to 20 multiplied by 3 plus 40. Alright, so this should be equal to 100, and the units is radians per second, and this is given by the problem. Okay, so now that we have this angular velocity of this disk A, what we can do is let's evaluate a point here at this disk A. So let me draw it over here. So I'm gonna draw here a point, and I'm gonna call it point 1. And by evaluating this point, well, this point and any point in this belt should have the same velocity. Therefore, we can say that this point over here should have the same velocity. Therefore, I'm just also going to call it point 1. So, and what is this important? Well, it is important because we know that the velocity of a point, if we know that the angular velocity and we know the radius, then we can find its velocity, and that's our case. We have that our point velocity will have the angular velocity times the radius. Okay, so let's just start by doing that. So we have that the velocity of point 1 is going to be equal to the angular velocity, WA, times its radius, so the radius of my disk A, and this should be equal to, well, angular velocity is 100 radians per second, and its radius, if we convert it into meters, is 0.075. And when we plug this into our calculator, or basically we can multiply it in our head, it's equal to 7.5 units is meters per second. Okay, so as I said, well, the velocity of this point should be the same as the velocity of this point. Now that means that I'm going to this point 1 again should be also equal to, well, the velocity of this disk B, so the angular velocity of disk B multiplied by the radius. Well, the radius from here to there is described by this 25 millimeters, so I'm going to call this one radius of D. Okay, so just to kind of like showing you guys that this little disk is called disk D, and the big one is disk B. However, both of them have the same angular velocity of B. Okay, so well, we know the we want to know the angular velocity of B, so we're going to solve for it. So we got W of B is equal to the velocity of point 1 divided by the radius D. Since we know both of them, right, so we have that 7.5 divided by this radius, which is equal to 0.025 if we convert it into meters. And when we do that, we found out that this is equal to 300, and the units should be in radians per second because it's the angular velocity. So we just found out the angular velocity of my disk B, which is one of the questions that they're asking. So very similarly, we're going to think about a point in here in our disk B, and we're going to call it point 2 in order to apply the same concept every single point around here should have the same velocity. So I'm going to call this point 2 just to keep things simple. So we're going to say that the velocity of point 2, and we're going to analyze it with respect to the angular velocity of disk B, is going to be the angular velocity of this B multiplied by the radius of B. And we know both of them. One of them is 300, the velocity, multiplied by the radius, well, it's 0.1 in meters. And when we multiply this, we will get a total of 30 meters per second. Okay. Finally, the same velocity of this point should be equal to the angular velocity of my disk C multiplied by my radius C. And if we solve for the velocity at C, should be equal to the velocity of this point 2 divided by my radius at C. We plug the numbers. 30 divided by the radius, well, the radius is this 50 millimeters, so 0.05 meters. And when we plug this into our calculator, we get a total of 600 radians per second. And this should be our second and last answer for this problem. So I hope you guys like this video. Please push the like button, subscribe, and I'll see you guys in the next one.